Yes, look at this next case. So in this next case, you've been told table 1 shows the scores distribution of the candidates interviewed to join a mechanical engineering class. So you've been given the scores and the number of candidates. So the number of candidates gives you the frequency F, isn't it? So you'll be told to determine the mean score, the median, the mode, and the standard deviation, isn't it? So before we get all this, the first thing we need to get, like a case of the mean, for us to get the case of mean, we need to have a single value representing each and every class, isn't it? So that single value is going to be denoted by X, the midpoints of each and every class, isn't it? So X, the midpoint of each and every class, introduce the column of X. So the column of X we are going to have, the midpoint of 10 and 25 is the average. 10 plus 25 divided by 2, isn't it? Yeah. Which is? 15. The midpoint of 20 to 30 is the average, which is? 25. The midpoint of 30 to 40? 35. The midpoint of 40 to 50? 45. The midpoint of 50 to 60? 55. The midpoint of 60 to 70? 65. The midpoint of 70 to 80? 75. Now, after getting those X, we've been told to determine the mean score. So here the first thing for us to determine anything, we have to know the total frequency. The summation of the frequency gives you the total number of students, N, isn't it? So when you add up all the frequencies, you get N, the total number, meaning summation F gives you N. So what is N? The total number of candidates. Add them, 60 plus 80 plus 90 plus 110 plus 60 plus 50 plus 40. 490. 490. Very good. So after you found the total number of candidates, for you to get mean score, the mean, because you represented the data value, let us start with the mean, isn't it? So the mean, when you represent the data value with X, then the mean is given by X bar, isn't it? And X bar we show was the expected value of X, isn't it? Expected value of X means you are summing up all X values and you are dividing by that total number, isn't it? So summing up is denoted by that big symbol summation, isn't it? So you are summing up all the X. When you are summing all these X, you multiply with the number of times they appear, because some of them are appearing more than once, isn't it? Meaning if you want to add 15, you are going to add 15 60 times, isn't it? 15 plus 15, 60 times. So adding up 15, 60 times is like multiplying 15 by 60, isn't it? So summing up all X, you sum them with the number of times they are appearing, isn't it? Then when you divide by their total number, then you would have found their mean, isn't it? And the total number N you sum is like summation of F. So it means N is the same as summing up all the frequencies, isn't it? So this is the same as summation F, isn't it? Good. So after that, it means we already have N to be 490. So what we need is Fx, isn't it? So it means you introduce a column of Fx, then we sum them, isn't it? So go to the calculator and you start the column of Fx, F times X. 60 times 15, you get? 900. 900. F times X, 80 times 25? 2000. F times X, 90 times 35?
3150.
3150. F times X?
4950.
4950. 60 times 55? F times X?
3300.
3300. Go on, 50 times 65?
3250.
3250. Then you go on, 40 times 75? Yes?
3000.
3000. So you see, you've summed all, you've multiplied all Fx. Now you want to sum all Fx. So when you sum all Fx, if you sum all of them, what do you get?
22550.
220?
2550.
25? 2550. Very good, isn't it? When you add up all the Fx, you end up with 2550. 2550. Are we together? Now, what we need to do is just to substitute. Summing up all Fs, we found 550. Then we divide by the total number N, we found to be 490, isn't it? So in the end, what do you get to be the mean?
41.94.
41.994. Very good. So you would have calculated that The mean. After the mean, you'll be told to find the median. So for you to get the median, you must know how to locate the position of each and every data value, isn't it? So the position of each and every data value is going to be determined by the cumulative frequency C, isn't it? So you introduce a column of C. So in the column of C, it is the frequency you are checking. At the end of this column, you would have counted 60. See there? Then at the end of this column, you've counted 60 and you are counting 80 more. At the end, you will have counted a total of 140. Then at this point, you've counted 140 and you are counting 90 more. At the end, you will have counted 200 and then at the end there, you've counted 230, you are counting 110 more. At the end, you will have counted 300 and 340. Then at the end there, you've counted 340 and you are counting 60 more. At the end there, you will have counted 400. Then at this point, you've counted 400 and you are counting 50 more. At the end there, you will have counted 450. Then here 450 and you are counting 40 more. At the end, you will have counted 490. So if you counted 490, 490 is the 490th term, the last term, isn't it? Meaning you've counted everything, isn't it? So the cumulative frequency will locate for you the position of each and every data value. So if you now want the median, you know the median is given by the lower class limit of the median class into n over 2 to represent the median. N over 2 is used to represent the median. Note that you take the n value and you divide by 2, isn't it? It is just a representation of the median. Are we together? To show that it is halfway of the data values. Are you seeing that? Then minus C, which is the cumulative frequency of the class above the median class, because we are using the rank order from lowest to largest data value, isn't it? Over F, the frequency of the median class, then everything times the class A interval. So you know the class interval is the upper class limit minus the lower class limit. So the first thing you will have to determine the median value, isn't it? So for you to determine the median value, you go to n. So our n is 490. So 490 means there are two values in the middle, isn't it? So two values in the middle, what do? We said the median value n over 2 will imply what? It will imply n plus 1 over 2, meaning it will be 490 plus 1 divided by 2, which you get to be 245.5. What we were saying, that when the data value is even, there are two values in the middle, isn't it? One of the value is 490 divided by 2, which is 245th term. Then you add 1 to it, you get 246 term. Then it means when n is even, there are two values in the middle. So instead of getting the median of 245 and then getting the median of 246 and looking for the average, just take their average at once, meaning 245 plus 246 divided by 2, you'll still get the same thing. Are you seeing that? Yes. So we are saying, don't look for the median of the 245th term, separate, and the median of 246th term, separate it when you look for the average. That is a long process, okay? Take the average at once, and taking the average at once is like saying n plus 1 over 2, isn't it? Meaning you've taken the average at once, because you can see this plus this divided by 2 gives you that. So n over 2 in case of a median just implies n plus 1 divided by 2 for both even and odd, because if it was odd, there's only one value in the middle, isn't it? And you add 1 to n and divide by 2, meaning n plus 1 over 2 for represent the median caters for both even and odd data value. You've already found the average of the values on the spot. Are we together there? So where there is n over 2 is represented by n plus 1 over 2. Are we together? Yes. Are we together? Yes. Don't ever mess there, okay? Yes. Because some of you will just come and take n and divide by 2, because here it is written n over 2, then they take 490 divided by 2 and they write 245 here. That is very wrong, isn't it? Are we together? Yes. Very good. So n over 2 is just a representation of the median, okay? So where there is n over 2, you put the value of n over 2, which you found to be what? 245.5. So we have 245.5 minus C. So why have we substituted the value of n over 2? Because C must be less than 245.5, isn't it? So you go to the column and see and you check the value which is less than 245.5 from downward. Which one is less than it from downward? 230. So 230 is less than it, meaning the median class is the class below it. Are you seeing? because C was the cumulative frequency above the median class. Are you seeing? So once you've identified C, which is above the median class, meaning median class is below it. Are you seeing that? The median class is below it. So once you identify C, you know C is above the median class, isn't it? So what is below is the median class. So I've identified C, which must be less than the median value, isn't it? Are you seeing that? Which is 230 is what is less than 245.5. So it means 245.5 term is in this class. Are we together? It is in that class because you can see this class ended at the 230th term, meaning that term number 231 to term number 340, all of them are in this class. And you can see there are 110 terms, isn't it? Then you can see term 245 is between term 231 to 340. Isn't it? If this class ended at 230, meaning this one started at 231 and it ended at 340, isn't it? So you can see 245.5 is in that class. It's between 231 to 240. Are we together? But the best way to see it is by looking for the value of C which is above it, isn't it? Okay? Yes. Good. So once you've identified the median class, you come and write it below here. So you've identified the median class to the class 40 to 50. Then after identifying this class, you identify its class limits, isn't it? So in this class, that class ended at 40 and this one started at 40. The average of that limit is 40 plus 40 divided by 2. You get the limit is still 40, isn't it? And this median class ended at 50 and this one started at 50 again. The average there is 50 plus 50 divided by 2. You still get the upper limit to be? Meaning in this case, the class limits were the same as class boundaries. Are we together? So from the class limits, you can now see the class interval I. Upper class limit minus the lower class limit, 50 minus 40. You get I to be? Then from this class, you can see the frequency of this class, 40 to 50. What was the frequency of that class? 110. Then now you substitute the values in the formula, isn't it? Are we together? So the median is going to be the lower class limit of the median class, which you've written here, 40. Are you seeing that? Which you've represented there is 40. Then it is plus 245.5, the median term, minus C. That was the cumulative frequency of the class which was above it, which you found to be 230. Then over F, the frequency of the median class, which you found to be 110. Then everything you are multiplying with the class interval, which you found to be 10. So if you substitute all this in the calculator, what do we get with the median? This minus this, divide by this times 10, then you add 40 to it at the end. Or just put the whole of it in the calculator at once. What do you have? What do you have? 245.5 minus 230 divided by 110, then times 10, then you add 40. Or feed the whole of it at once. You have 41.91. I hope everybody's there.
41.41.
0.41.
Yes.
41.41.
Yes.
Oh, good. So the median is 41.41, and you can see 41.41 is between the class limits of the median. It is between 40 to 50, isn't it? So you would have found the median value. What is important is that n over 2 is used to represent the median. But when you're now looking for the median value, it is n plus 1 divided by 2, isn't it? To accommodate both odd and even data set. Is that okay? Are we together there? Very good. So you found the median. The next thing you are looking for is the mode. So the next thing we are looking for is the mode. So the mean we found to be 41.94, and the median we found to be 0.41. Now we are looking for the mode. So can we now get the mode? So we said the mode is given by just the same way the median is. What is inside is what is different, isn't it? The lower class limit of the model class plus D1 over D1 plus D2 into class interval, isn't it? Are we together there? Very good. So for you to determine the mode, what you need to do first is to determine the model class, isn't it? So the model class is the class with the highest frequency. So if you check the frequency here, which one is the highest frequency? The highest frequency is 110. So it means the model class is the class 40 to 50. So you come and write the model class there 40 to 50. So after you've written the model class, you now check what is the frequency of this model class. It is 110, isn't it? Are we together? In fact, there's no even need of writing the frequency because we are going to get those from it's going to give us the D's, isn't it? What we need to write are the limits, isn't it? So what are the limits of this class 40 to 50? This class ended at 40, this one started at 40, meaning the limit there is average of 40 and 40 is just 40, isn't it? This medium class ended at 50, this other class started at 50, meaning the average there is 50 plus 50 divided by 2, isn't it? You still get the upper limit there to be 50. So the class boundaries are the same as class limits, isn't it? So in that order, upper class limit minus lower class limit, you get the class interval, isn't it? Which is 10. Then now what you are getting is the D1 and the D. D1 is the frequency of the model class minus the frequency above it, isn't it? Are you seeing that? Because here is where we have the D1 and the D2. So D1 is here in the middle, frequency of the model class minus frequency above it, meaning it is 110 minus 90, isn't it? Yeah. You get D1 to be 20, then D2 is the one in the middle there, 110 minus 60, the frequency below it, isn't it? So 110 minus 60 is 50. Then after that you can now see D1 plus D2 is 20 plus 50, which is 70, isn't it? See, now we have everything. After we found everything, we now substitute in the formula, isn't it? So when you substitute in the formula, you get the mode is lower class limit of the model class, which is 40, senor. Then it is plus D1. D1 which you found to be 20 over D1 plus D2. D1 plus D2 which you found to be 70. Then it is times the class interval which you found to be 10. So if you work out the whole of this in the calculator, what do we get to be the mode?
42.85.
42.85. Very good. So the mode is 42.85. So we found the mode is 42.85. Are we together? Having determined the mode, the next thing we are now looking for is the standard deviation. So the standard deviation was what? Was the sum, the average of the squares of the difference of the data values with the mean, which we simplified and we found it was just the expected value of x squared minus the mean squared, isn't it? Are we together? So can we go? That was the variance. Then the standard deviation was now the square root of the variance, isn't it? Is that okay? So it means for us to determine the standard deviation, we have to get the variance, isn't it? Standard deviation was the square root of the average of the squares of the difference of the data values from the mean, isn't it? Which was giving you the square root of the variance. So you have to get the square root of the variance. So you have to get the variance first. So what is the variance of x? So the variance of x was given by what? The expected value of x squared minus the mean squared. So when you talk about the expected value of x squared, it means we're looking for the mean of x squared. So the mean of x squared is x squared bar, isn't it? Then minus the mean squared. So you see this one square is inside, the other one square is outside. You see, they're two different things. Are we together? So if you don't like this kind of notation, you can just leave it at this point. So at this point, you know expected value of x squared is the mean of x squared. And what is the mean of x squared? You are summing all the x squared values and the number of times they are appeared, isn't it? Then you are dividing by their total. That is the mean of x squared, isn't it? Then minus the x bar squared, the mean squared. And remember the mean you've already found. Are we together? So it means we know what n is. 490, we know what the mean is. We found it there. What we are now looking for is the summation of fx squared. Meaning we need a column of fx squared only. Isn't it? Are we together? We only need a column of fx squared. So remember, as we say, when you are looking for the column of fx squared, you don't square the column of fx. Because if you square the column of fx, you'll get f squared x squared. And that is not what we are looking for, isn't it? Are we together? Yeah. So you take f times x squared. F is 60 times x is 15 squared. Only x is squared. Are you seeing that? Then you are done with that first row. You do the same for the second row. F is 80 times x squared. 80 times 25 squared. In that order, isn't it? Are we together? So can you now get me the value? Start with the first one. F times x squared. F by 60 times 15 squared. 13,500. Move to the next one. 80 times 25 squared.
50,000.
50,000. Move to the next one. 90 times 35 squared.
110 to 50.
110
To 50.
110 to 50. Then 110 times 45 squared. You get 220.
270.
223.
222,750.
222, 750. Then move to the next one. 60 times 55 squared. 181,500. Then f times x squared. 50 times 65 squared.
211 to 50.
211 to 50.
Yes.
Then you move to the next one. F times x squared.
225,000.
220. 225,000. So if you sum all the fx squared, what do you get if you sum all of them? 1. If you add up all of them, what do you get? 1 million?
10, 14 to 50.
10, 14
50.
to 50. You get 10, 14 to 50. 1,014,250, isn't it?
See, there you have x and fx. What if you just say this x times fx, you get fx squared. Now 15 times 900, you get 13,200. X squared.
When you are, yeah, it's just that the same as squaring 900 and dividing by f, isn't it? Yeah, it is the same, because if you square fx, it is going to be f squared, x squared. Then if you divide by f, you get fx squared. So it is just saying 900 squared divided by 6, isn't it? Senor?
Yeah.
Then it is the same as saying 200 squared divided by 80, because you are removing one f after squaring it. Senor? Huh? Or what were you saying?
I'm saying,
Yeah.
you have x
Yes.
and you have fx. Just say it is x times fx.
Yes, that is still the same thing. In fact, you are now the guy. You are the one who has seen it together. Yes. Very good. That is very good. That is the simplest. That guy has it. That is the simplest. If you take x times fx, you get fx squared. That is the simplest, isn't it? Very good. That is the simplest. So you have 15 times 900, you still get the same thing, isn't it? That is very good. That is very good. So you end up with 1,014,250. So at the end, what do we have here? You substitute. The summation of fx squared is 10, 14 to 50. Over their total number n, which is 490, isn't it? Then minus the mean squared. The mean you found to be 41.94 squared, isn't it? Are we together? So what do you get to be the variance? If you work out this in the calculator, what do you get to be the variance?
$311.03.
311.03, isn't it? So variance is 311.03. You have a different value. It is the same value, isn't it? Then after getting the variance, we want the standard deviation. So the standard deviation, SD, is the square root of the variance. So the square root of the variance. So what do you get to be the standard deviation?
17.63.
17.6? Very good. So the standard deviation is 17.63. And you would have answered all the required. Are we together? Yes. Very good. So that is what you expect in that case. Let us see another case still dealing. It is different. The square root of 311.03. Those are the same because those are approximated values. Remember, this mean with us we took it to two decimal places. When somebody else did another different number of decimal places. Those are very infinitesimal changes does not bring controversy here. Are you seeing that?
Yes.
So whether you have your 310.09 and 311, see those are approximately the same value.
Yes.
Because the mean people had different approximations, isn't it? That is still right. There's no problem. Are we together? That is still right, still the same. There's no big difference there. So whether here, what did you get there? You get 310.0.09. 0.94. So 310.94 and 311.03. So those are approximately the same thing. It's resulting because of these approximated values, isn't it? Yeah, there's no problem there. Then from your 310.94, what did you get? 17.67. Those are same things. There's no problem there. Because we are dealing with the decimal here. So his value is right, your value is also right. Okay? Good. That is what you expect there.